Welcome back everyone to the build series. This is the second video in this Flowbench build. If you missed it in the first video, a Flowbench is essentially a device that generates airflow and static pressure, and it's used to performance test cylinder heads, so kind of a before and after modifications to improve power in an engine. This Flowbench was primarily designed off of plans from the PTS forum, but have been modified to meet the customer's desires, needs. This video is going to pick up right where the last one left off, and that is on the right hand side and getting those seals attached to the cabinet. Wrapping up this door installation is a way to constrain the door against the seals that are going to be held in place. You can see a couple examples up in the top corners, but I need some way to hold it on there and really compress those seals. So the first thing I was thinking was that I made these little blocks, which you saw. This would be a clever idea that I could glue on to my my bulb seal retainers, and then put 1/4 inch 20 bolts in there, really squeeze it tight. And then I got to thinking, I'm sealing off this whole perimeter to keep the air that's in here in there, right? And now I'm going to put this on the inside of the seal region and drill a hole in my panel, in my door. So after making these and realizing that I'm dumb, I said I probably shouldn't do that. So back to the PTS forum, and there's a clever idea that I think Bruce did that mentioned, and it's using cross dowels, or I don't know if you call these barrel nuts, cross dowels, one of the things, and you can use these in your case, if you will. Drill a hole in your door, drill a hole in the edge of this, and actually compress it that way, which is pretty clever. I am maybe a little concerned about the longevity of the MDF and this kind of pressing on each other a little bit, but I think it's going to work. But I think it's still going to work. So what I need to do is take off the bulb seal constraints here, and then put my door, which is right here, put my door up in place and trace exactly where all the internals are at, or I should say all the casework's at, because I want to get all the holes centered on the casework, but I also need to make sure they align with the door, if that makes sense. So my plan is to mark my lines, drill a small little hole from the back side so I know exactly where I need to drill my big hole for my 1/4 inch bolt, and then drill that straight through the door into the case, and then hopefully that will keep everything aligned, and I won't have to make one of the holes super huge to fit the bolt through. So that's what we're doing. I'm gonna try that and give that a go. I've moved on to the third and final door of this build here, and this is this what I'm calling like an inner access door. So, you know, the door that's on the very front is kind of cosmetic. It covers up and hides some of the wiring and controls and the slider plate. This inside door is going to be what allows you to gain better access to the back side of the vacuum motors. So right now, I haven't cut out the panel yet, but there'll be an opening here that you can get and access all the vacuum motors. Usually you could do that from the side if you only had 8. So this, the plans have been modified to stretch this distance 8 more inches to get another row of vacuum motors in there. And getting to this top corner, if there's a vacuum motor way up there in the corner, it's going to be quite a reach from that side panel. So it seemed to make a lot of sense to add an extra panel or an extra opening in here. It's not huge, but it's going to be a lot better than nothing. So what I'm up to now, first off, piano hinge has been mortised into the door fully, a full mortise. So when this closes, the door is sitting flush on this inner panel. And so what I'm doing now is I'm actually marking. I've already drilled some pilot holes along the perimeter here, and then I'm putting thread inserts. So the way this is going to work is there's going to be a small seal around the perimeter of the door. You'd shut it, run some bolts down here to squeeze that tight and compress that seal to keep it, to keep all the air inside the chamber where it's supposed to be. In order to get to some of these other locations to drill out for the thread inserts, I actually have to take the front panel off. It's like right in line with where I want to put my drill. So I've started taking this apart anyway to start adding some of the internal kind of structure and webbing in there to reinforce the panels. So might as well just take that off now and get it out of the way. Alright, so it probably looks like the opposite of progress, but I am making progress on this cabinet for the Flowbench. I've deconstructed it back down to some of its individual pieces and components. The last assembly I got to take apart here is the selector assembly and the motor plate. So why I'm doing this is I need to cut the 45-degree angle in the front of the three pieces that make up the front, I suppose. That doesn't make any sense. I need to cut the 45-degree angle that mounts the kind of the console or the operator controls in the front there. And so I want to cut all those three pieces at the same time so they're exactly the same dimension, so that console piece fits nicely on there. And then I need to drill a bunch of holes for the selector plate assembly, and then I have to lay out all the motor locations and holes in the motor plate. So we're gonna move on to that. A bunch of hole making, 145-degree cut, and probably some other stuff. So here we go.
I wanted to explain what's going on here a little bit. I'm starting off by drilling this 5-inch hole with a hole saw in my selector assembly, and I'm drilling through the upper, lower, and the slider in the middle so they're all concentric. But what I really want is a 6-inch hole for airflow reasons and to reduce restriction. So after drilling the 5-inch holes, I come back with a rabbiting bit and make a 1/2-inch rabbet, so essentially making that hole 1 inch larger in diameter. I then flip it over and use a flush trim bit to make it that same diameter through its entire thickness, since my rabbiting bit needs something for the bearing to ride on. Anyway, but here I find out that my slider plate is not going to work because the hole is so close to the edge that airflow will sneak around it, so I need to remake it. Damn. So this is the motor registration plate, and the actual motor body will actually register inside this hole I'm making here. And I'm removing a bulk of the waste of the jigsaw, coming back with my template and a pattern bit, and making them all consistent. So here's what the kind of finished piece is going to look like. You've got your motor plate, which has the 2-inch hole. You then got your registration plate, and then you've got these hold downs. So I made the hold downs as one big sheet with a bunch of holes in it, and then I cut it up into these smaller little, I don't know what you call them, little dog bone looking sections. And those actually hold the motors in place. And here I'm laminating the registration plate to the motor plate.
Alright, so the cabinet is back together now. In order to fit the last remaining pieces, which is the top, which is a 2-ply layer of MDF, and then the front console here where the controls will go. As well, I was able to finish, before assembly here, I was able to finish out all the motor mounting and the registration stuff and the hold downs. Those are all done. That was a kind of a major hurdle to get all that accomplished. And so now it's assembled, everything's fitting pretty nice. I do need to take off the front console and the top again because I have to inset some like switch panels. So I had some 1/4-inch aluminum plate here that I do have to rip down to size. So I have a special blade in my table saw, and I'm going to give that a shot. And then I got to make a little template that fits around this out of just some strips of MDF that I can use to guide my router to cut out this shape in the console. So there'll be 2 of them, one here, one over here. And then for the top, I'm insetting there's a hold down plate as well as an orifice plate that I will be flush mounting, or I guess recessing into the top so it's flush. So gotta do that yet. And then I have to do some other internal bracing with just strips of MDF, some glue, and some brad nails. So that will be pretty quick and easy. Then after that, I think we're about time to sand and prime, I think. So here we go, gonna get back to it.
I think we're going to end this video on a high note, getting the hold down plate recessed as well as those switch panels recessed into the console. I really appreciate you sticking around for this second video. Please stay tuned for the third and final video. Make sure you subscribe so you don't miss it.